Infrastructure as code. Infrastructure as code, also short for IAC, is a key DevOps practice that involves managing and provisioning computing infrastructure through machine readable scripts or code rather than through manual processes. This approach allows for consistent, repeatable, and automated infrastructure management, which helps reduce human errors, speed up deployments, and improve the scalability and reliability of IT environments. Some of the key tools that we're going to look here are Terraform, CloudFormation, Pulumi, Ansible, and SaltStack. Now let's go through the first one, which is Terraform. Terraform is an open source IAC tool developed by HashiCorp. It allows users to define and provision infrastructure using a high level configuration language known as HashiCorp Configuration Language or HCL. Terraform is cloud agnostic, meaning it can manage infrastructure across various providers like AWS, Azure, Google Cloud, and others. Some of the key features of Terraform include cloud agnostics, where it supports multiple cloud providers and on premises environments. It's declarative configuration, which infrastructure is defined in a declarative manner where the desired state is specified. State management maintains the state of the infrastructure, allowing for incremental changes and ensuring consistency. It's modular, supports reusable modules, enabling efficient management of large complex environments. Community support. A large and active community with numerous pre-built modules are available. Some of the use cases include automating the provisioning of cloud resources, managing multi-cloud or hybrid cloud environments, and implementing and managing complex infrastructure setups. Here is an example for Terraform where I'm saying provider is AWS and the region at where this cloud is installed is at US West 2. Resources needed is AWS instance, which is called as example, and AMI that is using is AMI 1234567 Instant type is t2.micro. So this is how you can create a Terraform instance using the HCL language. CloudFormation. Now, AWS CloudFormation is an IAC service provided by Amazon Web Services that allows users to define and provision AWS infrastructure using templates written in JSON or YAML. CloudFormation automates the deployment and management of AWS resources, ensuring that infrastructure is consistent and predictable. Some of the key features include its AWS native, is designed specifically for managing AWS resources. It's template driven. Infrastructure is defined using templates, making it easy to replicate environments. Stack management manages resources as a stack, allowing for easy creation, updating, and deletion of infrastructure. Drift detection identifies changes in the stack's configuration and alerts users to inconsistencies. Integration integrates seamlessly with other AWS services like IAM, CloudTrail, and more. Some of the use cases for this cloud formation include managing AWS infrastructure for production environments, automating complex deployments on AWS, and ensuring consistency and compliance across AWS environments. Here is an example of cloud formation where I have a YAML file where you specify resources, which is in this case my instance, type AWS EC2 instance, properties are instance type is T2 micro, and image ID is AMI 1234567. Pulumi. Pulumi is an open source IAC tool that allows infrastructure to be defined using general purpose programming languages like Python, JavaScript, TypeScript, and Geo. This approach enables developers to leverage existing programming knowledge and tools to manage infrastructure. Some of the key features of Pulumi are it's code based, where infrastructure is defined using familiar programming languages rather than domain specific languages. It's multi cloud support, supports multiple cloud providers including AWS, Azure, Google Cloud, and Kubernetes. Reusable components allows the creation of reusable infrastructure components similar to software libraries. State management manages infrastructure state, allowing for predictable updates and rollbacks. Strong typing and testing offers strong typing IDE support and unit testing capabilities for infrastructure code. Some of the use cases include managing complex infrastructure using existing development skills, creating reusable and shareable infrastructure components, and integrating infrastructure management with application code. Here is an example of Pulumi using Python, where I'm importing Pulumi first and then I'm importing Pulumi AWS as AWS, which is an AWS module for Pulumi. Then I'm saying instance equal to AWS dot ec2 dot instance. My instance type is T2 micro, and AMI is AMI 12345. Ansible. Ansible is an open source automation tool that simplifies configuration management, application deployment, and task automation. We already looked at this at configuration management. Now, while it is primarily known for configuration management, Ansible also supports ISC through its playbooks, enabling users to define infrastructure in a declarative manner. Now, some of the key features include it's agentless, operates without agents or managed nodes using SSH for communication. A simple syntax uses YAML for playbooks, making it easy to write and understand. Idempotency ensures that the desired state is applied without redundant actions. Ansible Galaxy, a repository of pre-built roles and playbooks for common tasks. Extensibility supports custom modules and plugins. Some of the use cases include provisioning and managing infrastructure across different environments, automating configuration management and software deployments, and orchestrating complex multi-tier applications. Here is an example in YAML where I am providing the name, provisioning, and configuring web server. Hosts are web servers. I have task where the first task is install nginx and the second one is start the nginx server. SaltStack. SaltStack is an open source automation and configuration management tool that also supports IAC. It is known for its speed and scalability, using a high speed communication bus to manage large scale infrastructures in real time. And we already also saw this in configuration management. Some of the key features include its event driven architecture, supports real time event driven automation and orchestration. Flexible architecture, master minion setup with support for both push and pull configurations. Scalability, designed to manage large scale infrastructure with high performance. YAML based, uses YAML for configuration similar to Ansible. Custom modules, supports custom modules and states for complex tasks. Use cases include managing large scale dynamic environments with real time automation, automating infrastructure provisioning and configuration, and handling complex orchestration tasks in distributed environment. Here is an example of using SaltStack where I've created a YAML file and I'm saying that nginx is what I need, package installed, service running enabled it to true, requiring package nginx. Very simple and straightforward. Now, to summarize, infrastructure as code is a transformative approach to managing IT infrastructure, enabling automation, consistency, and repeatability in deployment processes. Tools like Terraform and Pulumi offer cloud agnostic solutions, allowing infrastructure to be managed across multiple providers using either declarative or code based approaches. CloudFormation is ideal for AWS centric environments, providing deep integration with AWS services. Ansible and SaltStack bring additional functional flexibility, combining configuration management with ISC capabilities. Together, these tools empower organizations to efficiently manage and scale their infrastructure, reduce manual errors, and accelerate deployment cycles, all while maintaining a high level of control and visibility over their environments. If you have any questions on infrastructure as code, leave them in the comments and I'll get back to you as soon as possible.